do is get rid of that ketone. And so chemists have developed all kinds of different reactions to do this sort of thing. And the first is that we want to reduce this ketone to an alcohol. And so the first thing to do is to reduce this ketone in the presence of the ester. And so the easiest way to do that is just to reduce it with sodium borohydride in a solvent like methanol. And sodium borohydride will reduce a ketone like this, but will not reduce an ester under these conditions. And so we end up with beta hydroxyester now. So we can go another step further. If we take this beta hydroxyester and we add either a strong base or a strong acid to this and heat it for a while, quite commonly this is done with acid because it just turns out that it's a bit more facile in acid solution. So we'll say, for example, concentrated sulfuric acid, which is a nice dehydrating acid. Then we lose water across the alpha beta positions. And so we end up with the alpha beta unsaturated ester. So we've just lost that hydroxyl group and one of the protons from the alpha position. In general, that's because we would protonate the alcohol. It becomes OH2 positive, which is a good leaving group, and then immunization of the alpha carbon can then be pushed over to knock it off. We won't go through that particular mechanism, but it's essentially like an E1 type elimination. So now we have our alpha beta unsaturated ester, and we can go directly to our saturated ester in one step. So we again can reduce, in this case, generally you wouldn't use sodium borohydride, you'd use some sort of transition metal catalyst. And that can be a very wide range of transition metal catalysts, things like rhodium, copper, platinum. Quite commonly it's hydrogen over some supported platinum catalyst. And that will add hydrogen across that double bond.